Okay, module 11.1, radical expressions and rational exponents. So this is the rule in which we're going to live by. A to the m divided by n. So this is a rational exponent, which means your exponent's a fraction. And the radicals and how they relate. The denominator is the index of a radical, and the numerator of the fraction is the power of the value. You can either put the power on the inside, or it can be on that outside. Either way. I like to do it on the inside because I think it makes things easier. We're going to practice looking at things, and we're just going to rewrite some stuff. We're going to rewrite it in the opposite form. So if it gives it to us as a rational exponent, we're going to write it as a radical expression. So here, this is a rational exponent. We're going to write it as a radical expression. So I need a radical. The big number stays inside. The denominator, the 8, goes as the index, and the numerator, the power, stays as the power. And we've rewritten it. That's all we're doing for right now. So here they gave it to us as a radical expression. We want to write it as a rational exponent. So I need that 6, that base, to stay the same. The power goes to the numerator. Index is the denominator. So 6 to the 4, this. And we've rewritten it. Again, a radical. This time we have a variable as our base. The power is the numerator. Index is the denominator. So it's x to the 3/4. Looking at number 4, we're given it as a rational exponent, which means we want to write it as a radical expression. So the denominator is the index. The numerator is the power. So we're going to put the radical in there. Our bases are x and y. The 3, that denominator, goes as my index. And then my power, because it's going to both the x and y, I do need to put parentheses around that x and that y. Now, if you don't like to write it with the parentheses, you could rewrite it as x to the 5th and y to the 5th, giving it to both the x and the y. And number 5, it has a radical expression. We want to write it as a rational. So this whole thing is our base, so 2x over y. The power stays as the numerator. The index goes as the denominator. And there you go. You have rewritten it. So a lot of what we're going to do is rewriting today. There are some problems that we're going to look at that require us to rewrite and then simplify. So 6 and 7 are kind of one of those that we're going to rewrite and simplify. So we're going to rewrite this first as a radical. So inside we have negative 125. The 5th power is our index. The 4 is our power. Now, to say that we have negative 125. Negative 125 is negative 5 times negative 5 times negative 5. And it says we have 4 of these. So the first thing I want to do is go, all right, I'm going to break this down. I have negative 125 times negative 125 times negative 125, negative 125. It says I have 4 of them. And I know that negative 125 is a group of 5s, or 3 groups of 5s. So that's negative 5 times negative 5 times negative 5 for the first one. For the second one, I need 3 more. For the third one, I need 3 more. And for the fourth one, I need 3 more. So if I have 3 5s in each 125 and I have 4 125s, that means I should have 12 of these negative 5s. And it says, go ahead and group them in 5s. This index tells us that we're taking out groups of 5. If it was an index of 3, we'd take out groups of 3. Index of 4, we'd take out groups of 4. So I'm going to circle them. It's 1, 2, 3, 4, 5. There's 1. 1, 2, 3, 4, 5. There's 2. And we have 2 left over. So this would simplify down negative 5 times negative 5 on the outside. And on the inside, I would have negative 5 times negative 5, which is 25. This would be a radical of 5. And out here, I would have 25 radical 5 is what it would simplify down to. Now we kind of crowded in on our number 7 space, so let me create some room here. Number 7 says I want to take 3/4 81 to 16. So I want to rewrite it in radical. So I have 81 over 16. My index is 4. My power is 3. What that says is I have 3 of these. So 81 over 16 times 81 over 16 times 81 over 16. Now, I want to break them down into prime factors. 81 over 16 is like saying 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. So there's 4 of them. So this is 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. This is just one of these, and I need several more. There's my second group, and then here comes my third. This says to take out groups of 4. So I'm going to circle them in groups of 4. Here's 1, here's 2, here's 3. Now, because I circled them out, nothing was left inside. On the previous problem, we had some stuff left inside. This one we don't. So we're going to multiply it together. 3 times 3 is 9, times 3 is 27. 2 times 2 is 4, times 2 is 8. And there would be my final answer. In this one, there is no radical left over. All right, so we have another modeling problem I want to look at. It says the function r equals 73.3, the 4th root of m cubed is known as Kepler's law. Relates the basal metabolic rate r in calories per day burned and body mass m of a mammal in kilograms. The table shows typical body mass for some members of the cat family. We have house cats, cheetahs, and lions. They want us to rewrite the formula, first off, as a rational exponent. So it's in radical form. We're going to write it as a rational exponent. So to do that means we're just going to simply take, let me change my marker, that 73.3 is going to stay outside. But that m, it's going to become m to the 3/4. And that's written in as a rational. Now we're going to substitute 55 into the formula. And it doesn't matter which formula you use, you're going to plug this into your calculator. There's no way I expect you to do this in your mental math. So r equals 73.3, 55 to the 3/4. Now you do need to put the 3/4 around that 55. And when you plug it into your calculator, it should come out to be 1,500 calories. So if you're not getting that answer on your calculators, let me know tomorrow in class so we can talk about how to input that into your calculator. Knowing how to use your calculator is going to be crucial. Then we have one more part of the problem. It says from the table the mass of the lion is about 38 times that of a house cat. So I'm moving you guys over this way so you can see it better. So we have part C. They want to know the mass of the lion is 38 times. Is the metabolic rate the same or not? So what we want to look at is plugging in the mass to find the metabolic rate for both. So if we find the metabolic rate for a lion, that's 73.3 times the 170 to the 3/4, and that would give us about 47.1 as the metabolic rate for the lion. And for the cat, we do the same thing, but we're going to plug in the cat's mass, which is 4.5 to the 3/4, and that gives us about 3.1. Well, if I divide the lion by the cat, so if I take that 47.1 and I divide it by the 3.1, that only gives me about 15. So even though the lion is 38 times the weight of the cat cat's metabolic rate, or the lion's metabolic rate is only about 15 times that